Hello and welcome back to Math with Mrs. Becker. Today we are looking at Calculus, Chapter 0, Section 6. One of the things that you really want to be able to be comfortable with as you get into upper level math courses is assigning variables for unknown values. And so when I look at example 1, that's exactly what they want us to practice doing. Just simply assign a variable for things that we don't know the exact measurement. So if I look at A, we have a rectangle with a width equal to 1/4 of the height, okay? So this is our height, obviously, because this is longer. The width is only 1/4 of that. Well, we do not know the height, so let's call that X. We are assigning a variable for a value that we don't know what that is. So the height is X. Now the width is 1/4 of the height. Well, the height is X, so the width is X over 4. That's what they wanted us to do. So the width is 1/4 of the height. We don't know the height, so the height is X. Done. We just assigned variables to represent the dimensions of the geometric figure. Okay, now let's look at example B. It's really important when you have diagrams to make sure that you fully read the directions. So in this case, it says a rectangular box with a square base. Remember, your bases, if it is a square, that means that all of the measurements must be the same. So this is super important. Okay, so we have a rectangular box with a square base, and the height is 1/2 of the base length. So again, we have no idea what the base length is. So let's go ahead and say X. X is the base length. But here's the deal. Because it's a square, that is X, and this measurement is X as well. So it's important that we know that. The height from one base to the next, that is your height. Our height is 1/2 of the base, or we could say it's X over 2. That is the height. And remember from geometry, the height of a geometric figure is always the distance from one base to the other base. Okay? Here is a cylinder. The height equals the diameter. So the height, we don't know the height. So the height, we're going to go ahead and assign it a variable. The height is X. The diameter is the same thing. So the diameter is also X. Now, one other thing, because we're looking at a circle, as we move forward, they're going to have us look at some different formulas. Now, typically when you work with a circle, you do work with what's called the radius. And remember, the radius is 1/2 of the diameter. So the radius would be 1/2 of the diameter. The diameter is X, so our radius would be X over 2. And I'm just bringing this in because as we go to example 2, we're going to start looking at perimeter, area, volume, surface area, all of those things. So it's important to know that if you know that the diameter is X, the radius is 1/2 of that, so it would be X divided by 2. Okay. So for example 2, we want to write expressions that represent the perimeter, area, volume, surface area of objects. For part A, find the expression for the perimeter of A shown above. Now remember, perimeter is if you add up all of the outside edges. Okay, so it is the space around the outside. So if I am doing this, this is a rectangle. Across from the rectangle, you're going to have the same dimensions. So if this measurement is X, this measurement is X. If this measurement is X over 4, this measurement is X over 4. So if I am finding the perimeter, I have X plus X, because I have 2 measurements that match the height, plus I have X over 4 plus X over 4. I have 2 measurements that match the width. Now I need to have common denominators. So this is 4x over 4 plus 4x over 4 plus x over 4 plus x over 4. My common denominator is a 4. Remember, if you ever have a variable without a number in front, it is an unwritten 1. So 4x plus 4x is 8x, plus 1x is 9x, plus another x is 10x. So I have 10x over 4. I can reduce top and bottom by simplifying. Go ahead, divide top and bottom by 2. I would have 5x over 2. That is the perimeter of the top shape. Okay. Next, find the expression for the surface area. Now remember, surface area, what that means is you are finding the area of each face of the shape. So here, because I'm looking at B, I'm looking at our rectangular box. Remember that the bases are square. I need to find the area of the top and the bottom, as well as the area of all 4 sides that connect those bases, and you add them together. So again, it's being able to look at this and kind of dissect it. I have 2 bases, one on the top and one on the bottom. We're looking at the area. They told us that this is a square base. In order to find the area of a square, it's side squared. Our side measurements, we did not know what that was, so we assigned it as x. So we have 2 bases where the area is x squared. Then we have 1, 2, 3, 4 sides. 4 sides, they are rectangles because it's 1/2 x times x. So I have to multiply. So if it's x over 2 times x. Remember, when you multiply fractions, it is top times top, bottom times bottom. So this is x squared over 2. To find your surface area, I have 2 bases. The area of the bases are x squared. Plus, I have 4 sides. The area of each side is x squared over 2. 2 times x squared is 2x squared. Plus, when you're multiplying fractions, you can cross cancel. So I can divide by a 2. That would cancel. If I divide 4 by 2, I get 2. So 2 times x squared is 2x squared. These are like terms. They both contain an x squared. 2x squared plus 2x squared is 4x squared, and we're done. Okay, next, consider the cylinder. So this one's going to get a little bit tougher, but we totally have this. Consider the cylinder, see above. Write an equation expressing the fact that the surface area is 30 pi square inches. Okay, then write an expression for the volume. Now, if you have anything like this, I would go ahead and give you those formulas because it's been a while since you were in geometry, and the surface area or volume of a cylinder, that's probably not something that you have memorized in your toolbox, okay? So don't panic when I put this down here, okay? Our surface area formula that you do not have to have memorized is 2 pi RH plus 2 pi r squared. Okay, now what happens? The way that they got this, remember surface area, we just looked at that for B. You have to find the area of all of the different pieces. Now a cylinder, if I were to cut along this line and unfold it, you have a circle on the top and you have a circle on the bottom, and they are connected with a rectangle. Now remember, the area of a circle, I'm sorry guys, they're not matching when I'm looking at size, okay? But we're just visualizing what would happen. When you have a cylinder, if you draw what's called the net, you can see all the pieces. So I have a circle on the top. Area of a circle is pi r squared. Circle on the bottom, it is pi r squared. Now this right here, my friends, this is a rectangle. Okay, now when you look at this, we go ahead and we have this dimension is the height. This goes around the circle. Okay, around the circle is the circumference, which is 2 pi r. So when I find the area of this rectangle, it is length times width. One of the measurements is the height, distance between the 2 circles. The other measurement is how much you go around the circle. So the area of the rectangle, if you multiply them, it is 2 pi RH. I have 2 circles that are pi r squared. That's how they get the area of the circle. Okay, so when I go ahead and I find this, it is 2 pi, our radius. Remember, we said that the diameter was x, so our radius is x over 2 times our height. We did not know the height, so it's an x, plus 2 pi r. Our radius is x over 2, and you square it. Okay, so as I do this, I'm going to go ahead and multiply these. I can cross cancel this 2 with this 2. Remember when you multiply a multiply a denominator. I'm mixing up too many different words here. If I am multiplying by a denominator, it cancels. So pi times x is pi x squared. Plus, now here, this becomes 2 pi times x squared over 4. Because remember, when you square a fraction, you have to square both the top and the bottom. So this piece, I can cross cancel the 2 and make this a 2. So I have pi x squared over 2. I can make a common denominator here. 2 over 2, because technically this had a 1 underneath. So in order to make a common denominator, I would have to multiply both top and bottom by 2. My common denominator stays. This has an unwritten 1. 2 pi x squared plus 1 pi x squared is 3 pi x squared over 2. That is your surface area. And it says write an equation expressing that the fact that the surface area is this equals 30 pi. So we are done right there, folks. That's a little bit wild. It's a lot of geometry. Okay, so we did the first part. Write an equation. Equation must contain an equal sign. Find the surface area. Here was the formula. We used our cylinder from example 1, part C. We have this. Now, write an expression for the volume. The volume of a cylinder, all you need to know is that volume equals pi r squared h. And again, you would not have to memorize this. But now I can fill in our radius and our height. So it's pi. Our radius is x over 2. We have to square that times our height, which was our unknown value. That's an x. So if I'm going ahead and I'm looking at this, I square the top and the bottom. So it's pi times x squared over 4 times x. Top times top times top, bottom times bottom times bottom. Our volume, pi times x squared times x is pi x cubed. Bottom times bottom times bottom. 1 times 4 times 1 is 4. So there would be the volume for our cylinder. Fun stuff. Okay, let's move on. A rectangular box has a square copper base. So the base is a square, okay? So that means that all the sides are the same. And in fact, here's our measurement. This is the same as this, which is the same as that. It has a square base. It has a wooden top, and it has wooden sides. So the bottom is copper, everything else is wood. The copper costs $21 per square foot. The wood is cheaper, much cheaper. It's only $2 per square foot. Write an expression giving the surface area in terms of the dimensions of the box. Also, write an expression giving the volume of the box. So here, we know, let's say that this is x. Okay, so there's x. We don't know the height. They didn't tell us anything about the height, just that we have a square copper base and some prices. So the height, let's just go ahead and call the height h. Base. Okay, so if we are writing the surface area, I have two bases, the top and the bottom. The bases are square. The dimensions we did not know, so we said that they're x. X times x is x squared. Plus, we have four sides. The four sides that connect the two bases together. We have our dimensions, they were unknown. So x was the base, h was the height. So we have four xh's. That is the surface area. We are done. Okay. Now the volume. Volume of a box is length times height times width. So volume, length times height times width. Length times height times width. So we have x times h times x. So the volume is x squared h. Now, write an expression giving the total cost of the materials used to make the box in terms of the dimensions. So we have our surface area. Now remember, our surface area, that is how much it would be to build the outside. It's kind of like when you wrap a present, it's the amount of gift wrap it takes. We have one base that is copper. The area of that base is x squared. Copper is $21 per square foot. We have one base that is wood. The area of that base is x squared. Wood is only $2 per square foot. We have 4 sides that are all made of wood. All 4 sides have an area of x times h, and they are all $2 per square foot. Okay, so I have $21 times one base, x squared, plus $2 times one base, that's x squared, times $2 times 4 sides that are xh. So I have 21x squared copper bottom, 2x squared wood base, plus $2 for 4 sides, so it's 8xh. Combine our like terms, 21x squared plus 2x squared is 23x squared plus 8xh. This is a function that you could use. If you knew the dimensions of the base, that was x, you could fill that into x. If you knew the dimension for h, the height, you could fill that in, and it would tell you the total cost to build that rectangular box if the base is copper, the sides and the top base are wood. Okay, let's look at the next thing. Example 4. A toy manufacturer has fixed costs of $3,000. So fixed cost means that's what you have to pay no matter what, whether you are producing something or not. It's things like rent, your insurance, your business loans, okay? They have to be paid no matter how many toys are produced. In addition, there are variable costs of $2 per toy. So that means every single toy you create, the materials that it takes, so the stuffing, the fabric, the thread, that sort of thing, it's $2 per toy. At a production level of X toys, the variable costs are 2X, they're $2, and the total cost is $3,000 because it's fixed, how much you have to pay no matter what, plus 2 per toy. Find the cost of producing 2,000 toys. So the cost, we are producing 2,000 toys, 3,000 fixed costs, plus $2 per toy, we are making 2,000. Order of operations, you multiply first. 2 times 2,000 is 4,000. 3,000 plus 4,000 is 7,000. So it would cost $7,000 to produce 2,000 toys. What additional cost is incurred if they raise the production level from 2,000 to 2,200? So we need to figure out, okay, what is the cost now if we're producing 2,200? So 3,000 plus $2, but this time it's 2,200 toys. Order of operations, we have to multiply first. So 2 times 2,200 is 4,400. If you add 3,000 plus 4,400, we have $7,400. The question is not how much would it cost to produce 2,200 toys. The question is, what is the additional cost? So what you have to ask yourself is, what is the difference between 7,400 and 7,000? The difference is $400. How many toys can be produced if you have $5,000? So your cost, you have a cap on that, okay? You can only spend $5,000. So your cost could equal $5,000. Your fixed costs are $3,000 plus $2 per toy. We want to know how many toys you can make. So if I minus 3,000, I would have 2,000 equals 2x. Divide both sides by 2, x, which represents the number of toys created. 2,000 divided by 2 is 1,000 toys. Okay, here is one more piece. Let's say that the toys sell for $10 a piece. Okay, so that's your revenue. Revenue is how much money you collect, okay? So the toys are selling for $10 a piece. When X toys are sold, the revenue is 10 times X. Given the same cost function, 3,000 plus 2X, the profit for the toy manufacturer, profit is revenue. You collect your money minus your costs. You pay your bills. Whatever you have left, that is called your profit. Okay, so here the revenue is 10X minus our cost, 3,000 plus 2X. What we end up with is a profit statement. How much money are you actually making that you can put in your pocket, okay? Here's our profit, 8X minus 3,000. If the revenue from the production and sale of toys is $7,000, what is the profit? So we know the revenue is 7,000. So we have to take the revenue. Revenue equals 7,000. Revenue is equal to 10X. So if I divide both sides by 10, I can cancel a 0. X equals 700 toys. So that information, knowing that the revenue was $7,000, I could use the revenue function to find out that what we made were 700 toys. If we want to know the profit, now we use the profit function knowing that we made and sold 700 toys. So 8 times 700 minus 3,000. 8 times 700 is 5,600 minus 3,000. So the profit, if you make and sell 700 toys, how much money you would get to keep after you paid your bills is $2,600. One more page. 0.6 has a lot of different ideas. It's kind of cool stuff though. Okay, example 5, what we are doing is looking at a function in its graphical form. Okay, so we are simply going to read the graph to answer the questions. This is the height of a toy rocket. So it was fired straight up into the air. After t seconds, the height is shown. Okay, so t, that's your x value. It's the time in seconds. This is the height. S of t is the height, and it is in meters. At what time does the rocket reach its highest point? Well, here is the highest point, okay? That is its maximum. You can see it's increasing, it hits this point, and now it's going to decrease. At what time? The time is the x value. So the time is at 3 seconds. How far does the rocket travel in its last second? Well, its last second before it hits the ground would be from 6 to 7. How far does it travel? 112. This is 7 and 0. So in its last 1 second, it travels 112 meters. You could leave it like this, or you could say negative because it drops that much. Either way, I would accept the answer. So negative 112 because it's falling, or if you just say 112 because that is the distance, okay? What was the height of the rocket's launch pad? So when it was launched, what was the height right here? Now notice it's right across from here. So the height is the y value. The heights are going to match here because it's at the same y level on your y-axis. So the height of the launch pad is 112 meters. What is the height of the rocket after 1 second? Your y value is your time. So at 1 second, the height is 192 meters. After how many seconds does the rocket hit the ground? Well, it hits the ground here. Its height is 0. That is 7 seconds. And that, my friends, is 0.6. Hope you had a great time today. Talk to you soon.